today we are myself Tatkala Mahendra, working as assistant professor in Avanti Group of Educational Society, Hyderabad. So today we are going to discuss about food chemistry. So before going to be discuss about food chemistry, what is food? What is food? Can anyone know about what is food? Biological compound consists nutrition things. So what is the food? We will see, discuss. Food is a nutritional compound. You say that one. Good. Nutritional compound which help to the growth and development. Growth and development of organism. So maybe for example, we'll see. So for ourselves, for animals takes food, plants takes food. Even though microorganisms also takes food. Whatever may be, ultimately food is a food. The nutrient substance which will be promote the growth and development. Without growth, without any development, that is not comes under the category of the food. So this is the growth and development of the food. For example, we'll see. So this food may be divided into two types. So either maybe food may be divided into two types. Those are macronutrients and micronutrients. Macronutrients and micronutrients. For example, we will discuss about animal mostly. So what are the macronutrients? So we are taking a daily food, depends upon the rice, chapati, like that, whatever we do. So these micronutrients, which are mainly comes under the category of carbohydrates and proteins which comes under these macronutrients. Means daily we are eating chapati, either maybe food, rice, which are much more category of these carbohydrates. For example, when we take gymmers, along with this carbohydrate, they may take more quantity of the proteins. That means these proteins which gives the structure to the body along with the some energy. Then these carbohydrates which gives the energy to the body. Then these are some of the examples for these macronutrients. So what are the micronutrients? Micronutrients. For example, when we will take vitamins, and then maybe vitamins. Depends upon your pronunciations. Vitamins. Then coming to some of the ions. For example, sodium, potassium, calcium, etc. These are the which will be comes under these micronutrients. So what is the difference between this and this? So macronutrients we will take much more quantity. That's why it is called as macro. Macro means large. Micro means smallest, very small quantity. So these macronutrients again divided into two types: quantitative, semi-quantitative. So quantitative means which are most quantitative, means which are measurable in nature. Semi-quantitative means we can't measure with us those things. For example, so quantitative sodium, we will take daily sodium ions in the form of sodium chloride. So potassium, we will not take potassium, which will be supplied through the diet. So other potassium. So calcium, we will not take calcium directly. So it may take the calcium by through taking the milk. That means which is the most important in the children's. Children. So those will be calcium supply. That means which will be gives the energy to the bone, and so potassium which will be supplied to the heart, and sodium which will be regulate the every body organ. So these which will be comes under this. Then coming to macronutrients, carbohydrates and proteins and phenolic compounds and etc. Much more are there. However, these two are more important. These two are more important. So then we will go with this carbohydrates. So as per your knowledge, what are carbohydrates? As per your knowledge, what are carbohydrates? Have you know? Mostly chemistry students know about this carbohydrates. Sugars. So please, you say the word sugars. So what are carbohydrates? This. So as per definition, these are the polyhydroxy aldehydes. Aldehydes are ketones. Polyhydroxy aldehydes are ketones. So what is the carbonyl compound? Please. So what is carbonyl means? C double bond O is called as a carbonyl group. Carbon exists with the 4 bonds. So coming to valency, carbon existing with the 4 bonds. So as per this one, 2 bonds are existed with the oxygen. That's why it is called as a carbonyl function. So when this carbonyl functional group existed with the 1 carbon chain one side, another side hydrogen 19. These lead groups are called as a aldehydes. Then coming to ketones, these carbonyl functional group existed with this carbon chain, both side carbon chain. Either may be CH3, either may be C2H5, depends upon number of carbon, may be depends upon how many carbons we don't like. So we'll see these how many carbons we don't know. So when we see here how many carbons we don't know, those are called as a carbohydrate. So we denoted that polyhydroxy groups. So when we use poly means more than 2. Either 2 or more are called as a hydroxy group will be existing in a carbon atom. Means, for example, when we see the structure of this group, for example, we'll see aldehyde group COH and existed with the H. So we can treat it. So 2 or more hydroxyl group will be existed to the compound. The compound said to be carbohydrate. That means, so as per definition, polyhydroxy aldehyde of ketone. That means double bond of HC. So this is the aldehyde. So the name of this compound is 1, 2, 3. So this name of this one is a glyceraldehyde. So this same structure existed with the ketone group. We'll see. So ketone group means C double bond O and C. Same. It means hydroxyl group will be existed. Hydrogen. So same thing. So here aldehyde group will be present. Here ketone group will be present. Same structure. That means when we see C3, H1, 1, 2, 3, 4, H4, 1, 1, 2, 3, 4, 5, 6. It's 6. Then O3. This is the same molecular formula. So what are isomers? How you know isomers? Isomerism, isomers. Any substance which exists with the same molecular formula. When we see these two, 1, 2, 3, 1, 2, 3, then we come to 1, 2, 3, 1, 2, 3. Hydrogens 1, 2, 3, 1, 6. So C, 3 carbon atoms are there. Then 6 hydrogen carbon atoms, oxygen atoms are 3. Same molecular formula with changing in physical and chemical properties. Physical and chemical properties are called as a isomers, and the phenomenon is called as isomerism, which is the most important. So most of the carbohydrates which will be exist with this aldehyde form, their respective ketone form. These two are with one is example for the isomer of another one. So these carbohydrate may be existed with the same molecular formula, change in the physical and chemical functional group are called as isomers. And this glyceraldehyde, which is an example, which is one of the isomer of this, that's dihydroxy acetone. Hydroxyacetone. So, for example, when we remove this hydroxy group H, the name of the compound is acetone. So, what is the use of acetone for girls? Not nail polish, nail acne remover. That means to clean up which is the most important one. So, to clean the nail polish. So for example, unfortunately, today one girl wear yellow color dress. So then tomorrow another function is there. She want to wear red color dress. So matching is important. To remove that nail polish, they will use acetone to remove the nail aqua remover. So that is called the nail aqua remover. So this dihydroxyacetone is a derivative of acetone. So one of the two hydrogens which were replaced by this hydrogen moieties are called as a dihydroxyacetone. So these two are the isomers. So this type of question will comes in your exam, competitive exam. Then I ask you question like this. So which one of the following is the isomer of? Which one of the following is the isomer of glyceraldehyde? If they give a dihydroxyacetone, which is a one example. So I think maybe they will ask like this. So they will give dihydroxyacetone. Which one of the following is an example for this glyceraldehyde? So they may give the name of the compound, and then structure of that compound. So we want to know the chemistry. We want to know the structure of the compound as well as the name of the compound. So then coming to these all the things which are most important. So we will go with this classification of carbohydrates. So one of our friends said that one carbohydrates. He said that one sugars. Carbohydrates means sugars. So these carbohydrates may be divided into two types. Those are sugars and non-sugars. Sugars and non-sugars. For example, glucose. Glucose, I think very well about it. So when we eat glucose, are called as a sugar. Means the sugars are sweet in taste. Sugars are sweet in taste. Coming to non-sugars, they do not feel any sweet taste. Not a sweet. Not sweet in taste. And coming to sugars. Sugars again classified into two types. Sugars again classified into two types. Those are the monosaccharides. Monosaccharides and disaccharides. Monosaccharides and disaccharides. And coming to these monosaccharides, they are divided into again types, different types. That means monosaccharides which is made up of only one molecule. For example, in our class is there. So then they given one place to one person. Then one of the student will be sitting one bench. The single. Those monosaccharides like single molecules. So they are classified into different in the number of carbon atoms which will be present in it. Take for example, depends upon the number of carbon atoms. They are divided into trioses. Trioses means they are made up of 3 carbon atoms. Three carbon atoms. Then coming to tetroses. They are made up of 4 carbon atoms. Pentoses. 5 carbon atoms. Exoses. 6 carbon atoms. Heptoses. Octoses. Still means tetroses. Trioses means 3 carbon atoms. Tetroses means 4 carbon atoms. And pentoses means 5 carbon atoms. Exoses means 6 carbon atoms. Heptoses means 7 carbon atoms. Octoses means 8 carbon atoms. So in which pentoses and exoses are most important compounds. For example, these trioses, tetroses are very less compounds. We saw that example that dihydroxyglycerol. Dihydroxyacetal or glycerol. So these are the example for these one. So for example, tetroses, erythrose. Same. This aldehyde and ketone molecule will be present in it. Coming to this pentoses, ribose. So ribose is an example for the aldehyde group, and this ribose is an example for the ketose group. Then coming to 6 carbon, which is the most important. 6th carbon. So glucose, comma fructose. Glucose and fructose. So, for example, honey. You know honey? How much sweet is it? More than sugar. So, highest sweet taste is the honey only. In entire world, highest sweet is the honey. So, due to this fructose present in honey. Due to fructose only, it has much more sweet taste, which is one of the question. As well as much more important things, these fructose will not increase the blood glucose levels. In the body. So for example, diabetic patient is there. They want to drink tea. They want to drink sugar. When we made the tea and sugar components with this fructose will not suffer any diabetic problems. So when we given this fructose to the diabetic patient, they will not suffer any problems, any disorder from it. Then coming to heptoses, octoses. So this heptoses and octoses are the compounds exist with the compounds due to the lack of stability. Lack of stability. For example, you are staying, you are listening this class. Unfortunately, you are not interested. If you go out, anyone object you? Anyone object you? No one will be object. Depends upon your wish. As like these ectoses and octoses, to get the stability, it will be converted into more compounds. Either maybe by lossing of the carbon atoms. Either maybe it may divide into one or two compounds. So this is coming to this one. Next coming to disaccharides. Disaccharides. So disaccharides are again divided into two types. Those are non-reducing sugars. Non-reducing sugars and reducing sugars. Reducing sugars and non-reducing sugars. So, example of non-reducing sugar. Table sugar. Oh, we'll see. So, example for this non-reducing sugar is sucrose. We know that one very important compound is sucrose. Sucrose is an example. Only one most important example for non-reducing sugar is sucrose. And coming to reducing sugars, we know that one lactose. What is the lactose? So milk sugar. So which will be present in the milk. So then this lactose which will be present in the milk, and this is an example. So then this lactose will be converted into lactic acid, which is the most important one. Lactic acid. So the lactose will be present in the milk and it will be converted into lactic acid by the microorganism lactobacillus. Lactobacillus. And this lactic acid will be present in the curd. Lactic acid present in the curd. So when we see the taste of the curd, some of the curds are somewhat sweet in taste. Some of the curds are very sour in taste. So depends upon the nature of the lactic acid. It means which is adding very less lactic acid in a curd. It means the entire lactose will not convert it into lactic acid. That sugar, that milk, maybe milk or curd having the sweet taste. If entire the lactose units will be converted into lactic acid, that having more sour taste. More sour taste. So these are the examples. So for example, one more is an example for this maltose. Maltose, which is an example for another example for this disaccharide reducing sugar. So why we are calling reducing? We don't know. So we will discuss in the tests of the carbohydrate later. Why? Just to know about the non-reducing sugar, reducing sugar. Example for non-reducing sugar is sucrose. Example for reducing